Well, welcome one more time for another event of Agile Austin DevOps SIG. This is the first time that we're doing a webinar, like many other teams may be doing these days, obviously. And but we are obviously as well eager to keep providing good content for our members, not only of Agile Austin, but also people that are joining us from different parts of the country and even in Canada, like Nazima. And usually what we do is first we will go with announcements. So is anyone searching for a new job? Just say I, or just drop some lines on the chat window. And what's your name? What are your skills? What are you looking for? That's always good to have some kind of networking. Okay, we'll leave that for you guys if you're looking for a job there. Then the other question is, who is looking for hiring people in your companies? That's another question. And if you guys have any open positions, just post them in the chat window likewise, please. Now, guys, do you have any interesting events in mind? Obviously, most of them are webinars that we should be aware of and start attending to. If you have anyone in mind, please drop a message.
I have a plan for May, April 10th. I'm going to share the link at your meetup page.
Thank you, Nazima. That's fantastic. And let me post this in Meetup. I also have another schedule of events that were very interesting that I signed up for 2 of them already, and none of them disappointed. This is a series of events from a company called B2IQ that have a schedule for April, and even it goes through April and March. So let me put this one here. Thank you, Doug, also for the Wolters Kluwer. Is that how it's pronounced?
Yeah, Wolters Kluwer. It's a big Dutch company.
Okay, nice. What do they do in that company?
Lots of different things. My particular group does what's called tax compliance. We help people file their taxes for accountants and large firms. So we're busy. Tax laws always change, and we're always busy.
Okay, nice. And Bob, I saw that you also posted one from TSI Global Partner Payments Company.
Yeah, if you're the type to have strong opinions about DevOps and want to herd cats, about a team of almost a dozen. If you throw in our Scrum Master and Agile Manager as part of the team, it's a fairly larger DevOps group, I guess. But
you're right. Thank you. And yeah, I saw that, Doc, you also dropped the link for the careers site, so that's awesome. I posted the link to the D2IQ events agenda, so you can take a look at those ones. I signed up for 2 of them related to Kubernetes. Any other events that you guys are aware of? Or Jeffrey, do you have another one upcoming?
I posted that link next week. Next week, I'm giving a presentation on DevOps with GitHub Actions, which are growing pretty rapidly, using GitHub Actions as a basis for an automated DevOps environment.
Okay. Got it. Perfect. And yeah, if you guys have any other ones along the conversation, if you recall them, just don't hesitate to drop a line in the chat window. So with all of that said, well, for the ones that just joined, we have Heath and Troy. Welcome, guys. For the ones that don't know me, my name is JJ Ruescas. I'm the organizer of the Agile Austin DevOps SIG user group here in Austin, Texas. And thanks through the magic of internet now reaching way more people. The purpose of this user group is actually to promote continuous learning, specifically in DevOps and cloud areas. Fortunately, the term DevOps is very, very wide, which allows us to tap into development, PM, agile practices, testing, cloud engineering, architecture, etc. So if you're interested in following us, just we're going to keep organizing events as we do in the Agile Austin meetup.com page, and likewise the upcoming ones will be webinars. Just as a heads up, you can also find the previous ones that we had recorded in YouTube, on YouTube I mean, and if you need more information about that, I'm always happy to help with that. Now, without further ado, today it is a I'm very happy for this presentation because we're going to talk about Azure DevOps services. And our guest today, Jeffrey Palermo, is the CEO of ClearMeasure. So ClearMeasure is a company centered in DevOps practices, and it's one of the fastest growing companies here in Austin, Texas. Jeffrey has been speaker in several events, big events like Microsoft Ignite, Tech Education, VS Live, DevTech, and he's also a Microsoft BMP since 2006. He's a graduate of A&M University. Long back ago when we used to go physically to universities, right? Now things changed. But he's also a Iraq One war veteran. And personally, I can say that I've been following Jeffrey's career for the last 2 or 3 years. And I'm very happy, Jeffrey, that you are here with us today. So without further ado, go for it, please.
I appreciate it. Thank you, JJ. And I'm really happy to be sharing this topic with all of you. And we're going to kind of go through it. I know we have the lunch hour, essentially Central Time. So I'm going to be respectful of your time and make sure that we adjourn on time, right at or before 1 o'clock, but also leave time for some questions as we go through here. Thank you, Troy Giggum from the class of 94. Absolutely appreciate that. Feel free you have permission to unmute yourself and ask questions. You can also just discuss or ask questions, have the back channel over in the chat window. That's perfectly fine. This is a user group meeting, not just a presentation. So the more discussion, the better. And I think that these DevOps methodologies are so new that the entire industry is still learning. We are all learning, and even early adopters, everyone is learning and getting better. The space is moving. So I am so glad you're here. And if you're tuning in for this, it probably means that you want to get more done, you move faster, produce higher quality, so that you can deliver for your team, for your company, for your customers. And I know from experience that if you map out your software delivery process and then automate it, you will deliver more, and you'll absolutely love the business of software. But we have an enormous problem, a serious problem, and a problem that we're going to have to solve. Most teams automate the work for their own customers by producing software, but then they saddle themselves with new administrative work to build, deploy, and monitor the software that has relieved their customers of their administrative work. If you think about it, there's no reason that the cobbler's kids shouldn't have shoes, to use that analogy. And I work with teams all the time where one of their most senior, most capable developers is sometimes trapped by the task of deploying the software because he's the one who understands the software the best. So they take their best talent with the most experience with the software and reduce them to weeks full of administrative tasks. A deployment is a set of administrative tasks. You're copying files, changing a config file, configuring your credentials, starting a service, and then you do it over and over again. So, and we all got into software because we saw the tremendous power that was available to us. We can write code and make the computer do something that makes our lives and the lives of others better. So that we shouldn't settle for a process that takes people with technical creativity, that is you, and just turns them into a robot. And for you managers listening in, I want to share something that goes on in the brain of your people when they have to do these manual processes over and over again. We as humans, we're always on the pursuit of happiness. And whether we get fulfillment in serving others or making something new, if your people, they definitely are not finding happiness in the process of manual builds and environment configurations and deployments. They want to get it done as fast as possible so they can get back to why they got into software in the first place, to create things, to solve interesting problems, to make lives easier through that software. And as a result, the manual tasks have become error prone. And the more your team endures those tasks that don't bring us happiness and satisfaction, the more they become maybe open to considering other employers that might give them a better sense of satisfaction. So whether you're an individual developer or whether you lead a team, or if you're a manager in technology, I hope that this presentation, this topic has something for you. We are talking about the Microsoft space. All of my work is on the Microsoft platform, so we're going to be talking about that. But these patterns and architectural concepts, they'll translate into any platform. But for build and deploys, we'll be focusing on the Azure DevOps product when we are talking about a particular feature. But this will have some material for anybody, even if you're not even using those tools. So we're going to go through the DevOps challenge that often faces us, how we should think about and structure our pipeline, which is the DevOps environment, and then how to start. And the goal for this topic is the rules of thumb that the industry has really settled on that allow you to fall into the pit of success. That if you do it this way, it will work really well. Now, that's not to say that you can invent some new way to do it, but okay, you're on your own, invent someplace new. I'm going to share with you the patterns and the associations that have proven to work. And so if you follow these patterns, then you'll have a good time of it, and you'll fall into that proverbial pit of success. One user group giveaway that I'd like to offer is a free electronic copy of my book. It just went out to press last November, so it's a very recent book. The first half of every chapter is architectural in nature. So if you are not on Azure DevOps or even .NET, you just read the first half of every chapter and you'll be able to get some value from it. So go ahead and you can, I'll give you my email address later on the slide. Actually, it's right here on the slide. Jot it down or send a chat in the note. Either way, send me an email and I'll make sure that you get a ebook copy. And for the user group, if you stumble on this recording and I'm still able to do so, I'll honor that offer. All right, let's get past this. Also, I'm the host of a podcast called the Azure DevOps Podcast. You might be interested in subscribing to it in any of the podcast directories. All right, so there are 7 key elements to a DevOps environment. The pre-code design process, which is even before there's any automation, but we're automating away the tracking of work, and there are some important things to think about there. There's the structure of your version control system repository. There's the different types of builds, full system testing, that's important, where user experience testing goes, how to do production releases and then how to know what the system is doing, which is telemetry observation. In the DevOps world, observability is a key word. Now, I want to give you an analogy about how to think about DevOps. It could be water pipeline. So you've heard the term DevOps pipeline. Pipeline is a really good word because it gives us the proper image. And the image that I want you to have is one of smooth flow and beautiful, clean water to drink. Okay. So, DevOps, and the word was coined back in 2010. So now we are a decade into DevOps. And it's still early. It's not widely adopted. Everyone's kind of ramping up and figuring out how to do it. But with 10 years of DevOps behind us, there are 3 overarching principles in DevOps. The first one is flow. The second is feedback. And the third is continuous learning. Those are spelled out in the original book, The Phoenix Project, and then extrapolated on in the follow-on book, The DevOps Handbook. And so flow, feedback, and continuous learning. So let's translate those into a pipeline. When you have a pipeline, you have water flowing through it, and the goal is for your customers to be able to have crisp, clean, clear, drinkable water at the end of the pipeline, and for there to be continuous water pressure, for it to always be reliable, always be there, and always flowing at a predictable rate. So what we don't have is droughts where no water is flowing through the pipeline and nothing's moving through. We also don't have tidal waves where a mountain of water is just crashing through when they're, if they press the button on a water fountain, they get their head blown off by a tidal wave of water, right? You have smooth, predictable flow of clean water. So you have your flow, you have your productivity, and then you have your quality, which is the quality of the water. Now, a pipeline is the right way to think about it because it constrains the upper bound, but at the same time, if it's empty, then that doesn't provide any value. So we want the flow of software changes to be smooth and at the same pace and predictable. And we want clean water coming out the other end. That means 0 bugs. And so in a pipeline, you don't just send water from a sewage treatment plant out to houses. It's kind of not fun to think about, but treatment plants kind of recycle water and they get it ready for drinking by filtering out the impurities and extracting the great water and getting rid of the dirt and bacteria and whatnot. So in a DevOps pipeline, we want to have filters every step of the way, catching impurities and filtering them out. And we want to be moving at a consistent pace. So 2 things to measure: the corollary for the water pressure, which you think of gallons per minute. That's the throughput. We want to have a measure for productivity. We also want to measure for the quality. Now in software, it's bugs and what caused those bugs, and that's our corollary with water quality. So that's the way to think about it, which does have some conflicts with Scrum, which is highly productive because Scrum does have the event where the customer has to wait until the end of the sprint, whereas DevOps is a lot more in line or a lot more compatible with a Kanban style of flow. All right. See, hand raised.
I was just wanted to make sure that you didn't pass on the slide till this point. You're showing right now the red gate octopus deploy, right?
Correct.
I thought it got stuck.
Okay. Yeah, it was. All right. Awesome. Okay. So this next architectural drawing is the general structure of any DevOps pipeline. And this is a highly shrunken technical blueprint for that. That's one that's implemented with a mix of products: Azure DevOps Services, Octopus Deploy, and Redgate SQL Change Automation is a pretty popular products. It has a continuous integration build. It has a 3-tier deployment pipeline, And this is the top 1/3 of the architectural poster. If this would be beneficial to anybody and anybody wants it, just again, send me an email and I'd be happy to get you the high resolution version of this poster. We're going to go through some of this, but it kind of should outlines the key places that should be in each of these elements. And this is the flow. And I'm going to go through these in more detail. And the scenarios box in the bottom left, these are the basic capabilities that you need for any DevOps pipeline, for any application. And when you're putting together a series of environments for a DevOps pipeline, you need at least 3 environments. That's minimum. You'll never have fewer than 3 because there are 3 distinct types of environments. Everybody knows production. That's what your customer uses. You need at least 1 production environment. And if you're hosting an environment per customer, you'll have multiple production environments. Some salespeople need a sales level demo environment. Well, that's a production environment too, because if it goes down, you have a business disruption, which is the definition of a production environment. Business is getting done with that environment. And so from a classification perspective, it's just good to have that classification. The next environment type is a manual test environment. You're going to have multiple of those likely. Common names for those are dev, test, QA, UAT, staging. Those are environments where a human goes on there, does something, and either identifies an issue or clears that particular release candidate for promotion. The third type of environment that we find is missing in a lot of cases is the test automation environment. This is the environment that enables continuous integration to be implemented. The goal of continuous integration, which DevOps is the technical practices of DevOps builds on top of the work in the industry around continuous integration, which started in the 2000s. In 2007, there was a book published by Addison Wesley publishers called Continuous Integration, and it outlined the different build types that you need in order to implement the continuous integration methodology. You got your private build, which runs on a local developer workstation, and simple PowerShell script is great for that. But there's certain steps that need to be in your private build. We find with a lot of these build servers, people forego the private build, and so they only do a partial continuous integration implementation. You have your integration build, which is getting popularity because essentially you're just triggering a build. And then to finish continuous integration, you are deploying your application and starting up and verifying that it's still stable. The goal of continuous integration as a methodology is to answer the question of, with the changes that I just made, do I still have a stable application? Do I still have a stable code base? You have multiple people making changes, and that's a very important question. And so in order to answer that question, we need to not only integrate the code, merge it, make sure we don't have merge conflicts, build it, run whatever test suites that we have available to us, package it up in a deployable fashion. We also need to deploy it to a representative environment and start up the application to make sure that it still starts. Because it does us no good if the compilation passed, unit test passed, maybe some component level integration test passed, maybe some static analysis rule sets passed, but we then go to install it and it is completely broken. Okay. So continuous integration answers that question of, with all the changes from multiple different places integrating together, did we totally break our application, or is our code base still stable? And so a automated deployment and startup, and at least some tests to make sure that it started up properly, that's what you need to implement continuous integration. And we find that step is left out a lot. So if you're in a team that has an automatically triggered server-side build of some sort, that is a critical piece for continuous integration. But we find some people saying, oh yes, we have CI in place, but then that's all they have. And so they have about 25% of continuous integration in place. So anyway, I wanted to stress that because it's super important. because what the benefit of continuous integration is phenomenal. You make a change and you have an automated process to answer that question. Do I still have a stable code base? That's a super important question to have answered. All right. Here's a picture of the full poster. All right. So from a process perspective, you're going to have, I want to talk about the 4 pre-code design decisions that we have to make in order to enable a DevOps process. This is falling into the pit of success. You notice the developer step is step 5. We need, the conceptual definition is requirements. Users, what we normally think of, hey, what the heck are we doing here? User experience design, our screen mockups, what's it going to look like? What are the data types? How is a user going to experience something? Even if something runs under the covers and doesn't have any screens, there is a user experience, because if data gets from system A to system B, well, it's a difference if the data gets there within 5 minutes or if the data gets there within 6 hours. There's still a user experience component there. The next step is technical design. This is architectural changes. What libraries do we need to implement this new story? Any kind of technical decision. And then acceptance criteria. The element of Scrum around acceptance criteria has a great compatibility with DevOps, and the best implementation of it is bulleted test scenarios of steps, like step 1, log in. Step 2, navigate to some page. Step 3, type in some stuff. Step 4, click a button. Step 5, make sure that something happened. That's just a simple bullet list. That's super simple, and you can manually test it. But deciding what those scenarios are going to be really puts a vice around the scope of a particular item, feature, or story that's flowing through the process. And then from a team standards perspective, the developer automates and codes the acceptance tests as well in a full system test suite. So you have a unit test suite, you have a component level integration test suite for database queries and stuff. And then you have a third test suite, which is a full system acceptance test suite, which gets deployed to your test automation environment. We call it the TDD environment, and executes against a fully deployed instance of your application. And for web applications, you would use libraries like Selenium or Cucumber, etc. And so those are the 4 pre-code design process. And once you have these design decisions, developers end up going really, really fast. If you leave these out, then a developer sitting at the keyboard thinking, okay, what should I do? And then there's a gap in the concept of what should happen in certain scenarios. And the developers then having to back up mentally and do analysis to fill in a hole. Or maybe there's a screen mock-up, but the data types were not specified on the fields on that screen mockup. So they're having to think, okay, how long of a string should that be? Or is that a decimal field? And they're having to back up and do analysis, and they can't start coding yet because they're filling in the gaps. They're filling in design gaps. Or if technical design is done improperly or incompletely, they're designing a database table or thinking, or making build versus buy decisions on the fly, determining whether to do something custom or go get a library and bring in a new library to use. Or if the acceptance tests are not designed, if the test scenarios are not designed, they're having to kind of make assumptions about what done means. How many scenarios? Does it need to support all of these exception paths? Or is it okay just to say that these exception paths are not supported? So if we don't do these design decisions, then we're kind of handicapping our developers, and our throughput is going to be handicapped. This is what your starting point Kanban board should look like. If you're starting a new project and you don't already have some prior art establishing your columns, essentially your statuses of your, whether you call them stories or features, or if you're on GitHub and you just call them issues, or Jira calls them issues, whatever your unit of work that's flowing through your process, this should be your standard board. Now, there are 9 different concepts on this board. And I know some of the tools start out and they give you something that says not started, in progress, done. That is woefully inadequate. You're going to have lots of bottlenecks hiding. You're going to have stand-up meetings, if you do those every day, where a team member is going to say, yeah, I was working on something yesterday and I'm going to continue work on that today. That should be a red flag. That is a red flag that you do not have a good flow through your pipeline. Things should be at the level where they are understood, and that each item is no more than one man day of effort, so that you finished something yesterday and you have moved on to something today. Okay. So that's a red flag if you were working on something yesterday and you're going to continue working on that today. You should translate that to mean I am stuck. That should be a direct translation. Okay. So we see the first 4 design decisions: conceptual definition, user experience design, technical design, test design. And by the way, I don't care what you call these things. Rename them, make them different words, but they're concepts. Okay. So rename them, but have all 9 of these columns. You notice that development is smack in the middle. And in technical design and test design, we decompose items into smaller implementable pieces, so that by the time they get to development, each implementable piece should take no more than a day to get accomplished. And then functional validation is done at the development team level, and we recompose those broken down implementable pieces into the larger business scenarios. And then user experience validation is essentially manual testing with product management or stakeholders. And then release validation, that is whatever it takes to get it ready to release to production to our customers, and then do the release. And once we are in production, then we move it to the done column. And all these concepts are important. And add any of these, add additional columns if it makes sense in your process. But every column should have an owner, someone who owns the work to move it out of that column. All right. I think I zoomed in on this. I've already covered this. Now let's go to version control structure. There are some important rules here. The version control structure, the version control system is the headwaters of a DevOps pipeline. It is where it's the source of all the water that is flowing through the pipeline. Code changes. And so there's some rules that you need to abide by. If you follow these rules, then all of the products in the DevOps ecosystem will work for you. If you break these rules, you will be constantly fighting all of the products that are out there available for DevOps automation, because all the products assume that one versioned and deployable application comes from one Git repository. All the automation tools operate on a Git repository. So therefore, you do not want to put more than one application in a Git repository. If you're coming from a centralized version control system, maybe TFS or Perforce or Subversion, or any of the ones that allow you to essentially have a directory tree and only check out a portion of the repository. If you're moving to Git, you want to take that portion of the repository that represents one application, and you want to put that into a Git repository. So a build is going to operate at the repository level, not a portion of a repository. So you want to build everything in the Git repository together. Therefore, it should all be one application from an architectural perspective. It's okay to have a software system that has multiple applications and decomposed into multiple applications. Each of those applications is going to have its own Git repository. Now, one application can have multiple deployable components. Let me give you an example. Let's say you have an application that has a website, 3 backend jobs, Windows services, Azure functions, Azure web jobs, whatever it is, scheduled tasks, and then a SQL Server database. Well, now those are 5 things that have to be deployed, but they all are one application. They all are the same version number. They live together. If you have a maintenance window, they're going to be deployed together. If you have a 0 downtime, it's still going to be the same deployment event. So that's perfectly fine. That's normal. And in your Visual Studio solution, all the code would be in one Visual Studio solution. But I just want to stress that that's so important. And we see teams that are putting multiple applications in a single Git repository because they've migrated from from TFS or Perforce or Subversion, and it just doesn't work with the DevOps ecosystem of products. All right, so that's version control. Now let me talk about the important parts of a build. If you've been trained on test-driven development, then you can think of a build as a test. And a test has 3 elements to it. It has setup, it has execution, and it has assertions or validations. And in test-driven development, they're called arrange, act, assert. Okay, every unit test is arrange, act, assert. So with the build being a larger, higher order test, we have arrange, we have things to do to set up to do it. And those things are clean up from a previous build run, stamp a version number in there, and also to provision the build environment. In most business applications, the build environment is going to include your database. Okay, so in your build, you want to provision and create your database that will be used for the build. And so if you're using SQL Server, you would run your SQL database migration tool. You would spin it up, and now it would be ready. If your application needs a directory structure with some named subfolders somewhere, you would provision that environment. If it needs some environment variables, you would set those environment variables to values appropriate for the build. Then act, most of the time, the act is compilation. It's translating from source control to executable form. And because you've already stamped the appropriate things with your version number, when you compile, the compiled artifacts, your DLLs in .NET are going to be stamped with version numbers. In .NET Framework, you push it into a common assembly info.cs file. In .NET Core, you just pass it in command line. That works fine. Then assert is multiple steps. We'll run our unit tests first. They run super fast, and if they fail, it saves us time. Next, we run our component level integration test. This test suite is going to have queries, or is going to have tests that validate any database queries, our data access layer. And then there's one, depending on your level of maturity, static code analysis. If you're not using static code analysis yet, start by adding that into the build, but don't have it be an assert just yet. Don't let it fail the build, because it's going to give you a mountain of validation errors, and you got to tune your rule sets. Every coding language on the planet has static analyzers. You want to have that as a part of your build. It's going to find problems. And if you write significant amount of JavaScript, it's going to find tons of problems, because JavaScript is a terrible language. It's impossible for any person to write JavaScript without errors. I mean, it's so arcane just to know that if you're comparing 2 variables in JavaScript, you have to use triple equal. I mean, that's just a side edge case that everyone has to learn. So anyway, these rule sets are going to save us time. And then as you whittle it down and fix all the errors, then you can move the static code analysis to the assert column and then actually fail the build on any new static analysis errors, because you'll have a clean code base and you can keep it that way. And then the build needs to publish the test results. It needs to package up the deployable application components as labeled and numbered deployment packages that then make up a release candidate. We'll talk about that in a second, and then publish those. So as we're mapping, as we're packaging, we want every deployable component to be packaged appropriately for its destination environment type. So if you have an ASP.NET web application, well, that's going to have a package. The default package type in .NET is the NuGet format. And with Azure DevOps, we're going to store that in Azure Artifacts. Now, GitHub has packages. Zip files are pretty common as well for a package format. But you need to have every deployable application component have its own package. It's going to have its own name, but they're all going to share the same version number because they're all part of the same release candidate. Your SQL Server database is going to be packaged in a deployable format with all of those migration scripts, anything that's necessary to deploy that database, either a new version of that database or to upgrade a downstream target database. Your acceptance tests, that in-unit test suite, is also going to be packaged because it needs to be deployed to your test automation environment so that the right version of that test suite executes against the right version of your deployed application. So it's important just to map those. This is what your pipeline is going to look like in Azure DevOps Services in Release Manager. And you need to have at least three, one environment of each type. In the TDD environment, you're going to see that you're going to have tests that are running right after you deploy your application. And you're probably going to have a manual approval step to go to production. That's pretty much everybody does that. If we dive into one of these configurations, we see that it is very simple. If you see your configuration, and I intentionally am using the step templates, even though the YAML did come out last May, it's still being implemented. And for the integration build configuration, it's the most usable. But for deploying software, the design experience still needs a lot of work. So we still recommend using the step templates because it's a lot more approachable and it's fully implemented. You don't have feature gaps. For instance, if you're grabbing packages from Azure Artifacts and you're trying to use YAML, you're in a world of hurt because you can't pull a package by name. You have to pull a package by GUID. So you're configuring something just with GUID, and it just does not work well. But this is what your process should look like. If you have a lot of PowerShell step, you do not want to use this to create a program that has to be debugged. So at the beginning of our deployment, we want to tell Azure Application Insights that we're deploying. Then we have the same pattern for every deployable component. So in this example where we have a database and a web application, we have the same pattern twice. We grab the database package, we do some environment configuration, and then we have a step that does the deployment. So this PowerShell script just essentially executes our database migration tool. Now the database is done. Next, we grab the UI package, which is our ASP.NET web application. Then we do some stuff to prepare the environment. Then we deploy. Okay, that's it. So that's the pattern. It's grab the package, configure environment, deploy the application to environment in that order, and just order the components one at a time. After it's deployed, then we want to execute a self health check. In a web application, this is just essentially calling a URL on the deployed web application and asking the question, hey, are you healthy? Well, the application is the best one to know if they're healthy. And it's not enough for the web application to be online. And so a little bit of code that needs to run in the web application is a simple just query, kind of a ping type of query to the database to say, hey, am I connected to the database? Because if the web application has some dependencies that are not deployed properly, that are not online, well, then the web application is not healthy. It is not ready to go. And so this deployment should report failure because something went wrong. Okay. So that health check is really important to automated deployments. Otherwise, you're going to get bogus success reports where we had a successful deployment, but then you say, hey, so-and-so, go ahead and check it out. And then they go and the application blows up in their face because it's totally broken. You don't want that. If it's totally broken, that is a failed deployment. So you need that built-in health check in order to give you that information. Then in the TDD environment, now that it's ready to go, we want to download the package of our test suite, our full system acceptance test suite, poke in the connection string, what URL to test, and then let that in-unit test suite run and execute all those full system tests against the fully deployed environment. And then in an Azure-based and a cloud-based TDD environment, we can destroy the whole environment because we're elastic. We can just create it, run it, test it, destroy it. So the test automation environments are no humans allowed because we're going to start it up, deploy, run a test, destroy it automatically. That also proves every step of the way that we have the ability to create a new environment on the spot, which is important. Now, let me go through some branching. This is falling into the pit of success when it comes to branching. You want to have wildcard mappings for your integration build and for the TDD environment deployment so that changes on any branch benefit from the integration build, from the packaging, from the environment provisioning, from the deployment, and from the execution of the full system acceptance tests. So it all starts where we specify the test scenarios even before we change the code. Then on an engineer workstation on a feature branch, we change the code, execute the private build locally. Then we do a git commit and push. The integration build runs, packages it up. Then we do a deployment. Then the automated acceptance tests run in the TDD environment. Then it succeeds. Now I am ready to create a pull because I am confident now in what I just did on my branch. And I am confident that I did not just screw up the entire application. So I create the pull request, and then the team, whoever approves it, uses a team created checklist that essentially formalizes the inspection so that every time a pull request is reviewed, we're checking everything that we need to. All right, let's go into the next one. All right, this is deployment. Well, the point that I want to make here that illustrates is that there is no concept of I need to build to UAT or I need to build to production. We build and create a release candidate. And then that release candidate, made up of a set of packages, one for each deployable component, is deployed to any downstream environments. And if we were to add another manual test environment, for example, we should be able to deploy existing release candidates to that environment. We shouldn't have to make a code change and then rebuild. That's really important. All right, let me hammer on full system testing a little bit. Let me illustrate how this looks in Azure DevOps Services. In unit, you can write a line of code and tell it to take, you can tell Selenium or Cucumber or whatnot to take a screenshot. And then you tell in unit to capture an attachment. And it can be a PNG, a JPEG, or whatever. And so when you're running these full system tests with applications that have a screen, you want to take a screenshot every time you do anything. Space is cheap. I mean, this is such a simple thing you can do. Take a screenshot literally every step of the way. And then the next one zooms in. We can see we have a simple web application here where we have some navigation at the top and then a few text boxes and a button. Selenium is going through exercising this web application, and we have a step 1, step 2, step 3. And if something fails, I mean, how much time does it save when we can go and say, whoa, what did that screen look like at the point of failure? Because that prevents us from having to go and reproduce it and get back to what the screen looked like. If we can just look at it and say, oh yeah, okay, I know what's going on. I know exactly what the problem is, and you can fix it much more quickly. And so, yeah, you're going to have lots of attachments, lots of pictures being attached on every build, but who cares? Space is cheap. The second this fails and you're able to see exactly what happened, it saves so much time. So that's a simple technique that you should do just right off the bat. All right, so let's talk about some of the different things we do in the different environment types. We went over the 3 distinct environment types. We have production, we have a manual test environment, and we have a test automation environment. You never do anything for the first time in production. You only do things that you have done in pre-production environments multiple times. So, production, yeah, we're gonna migrate our database. In other words, there's a script that comes down the line that makes a column, a string column longer. Yep, we're going to do that in production. We're going to alter the table or add a column. We're going to deploy the application. We're going to run the health check. We do it in production. And we're going to load any static data. For instance, if we have a drop down of territories for mailing addresses, and those are kind of configured and it's static data, and now we brought on Puerto Rico or Guam or American Samoa, and it wasn't previously in the list. Well, that's static data. Guess what? We've got to load it. That's very common. And a new version of the application now includes a larger set of static data. That's normal. But then there's then there's other things that oftentimes are only done in the test automation environment or are only done sometimes in a manual test environment. And of course, your table of things is going to be application specific and a lot longer than this, but these are things that get run all the time. All right, let's talk a little bit about telemetry. Regardless of how many different deployed components you have in your application, you want information from all parts of your application to be pulled into a central repository. If you're using Azure, application insights should be the first thing you reach for. But there's lots of great products, Splunk, Stackify, New Relic, and there's more products coming out all the time. The key is that you want all of the information, not just logs, but all of the information from all of the parts of your application pulled into a central place so that you can query them together. And you want them to be separate from the environment itself. You want your team to have analysis capability on this telemetry of what this application is doing and what your users are doing with it, but you don't want to couple that access with giving them administrative access to the environments themselves. You don't want to have to give a big group of people admin access to production environment just to have their help in analyzing production issues. Okay. So you want to divorce the telemetry environment from the actual production environment. And of course, you don't want to emit any sensitive information in the logs and accidentally turn the logs into data that then is subject to data stewardship compliance regulations. So you want to take care about that. Now let's talk about what telemetry is. Logs have been in the software industry for a long time about just, hey, let's just emit something. Hey, what's the software doing from a procedural perspective? But most of you equip your customers or your business users with some ability to have a data warehouse, some ability to do data analytics with Excel, Power Pivot, or Microsoft Power BI or Tableau, or any of the great business analytics tool sets out there. But logs alone don't give that ability. We actually have a wealth of information with these applications, and we can unleash it by also emitting events coupled with metrics. And these are dimensions and facts, which are the building blocks of the Kimball method of data warehousing. And so every time somebody goes to a page, presses a button, does something, that's an event. If we give it a unique name and attach as many numbers as we can to it, and then emit that in a structured way, well, now we start building up a data warehouse style of information that we can use all of the same business intelligence tools in order to ask questions about what happened and slice and dice and group. And so that's a really powerful concept. Application insights get you kind of started just by hooking it up to your .NET application. It captures a ton of stuff in a queryable form, but you need to keep going. We talked about the deployment marker or annotation. That gives you the ability to see in application insights that, hey, we just did a deployment, and if things start to go sideways afterwards, kind of gives you that marker. If you click on it, then you have information that takes you right back to what build of the software was deployed, and a lot of good traceability. So those are the key elements of a DevOps environment. And if you have all these in place, you are going to have a world-class DevOps pipeline. You absolutely will. As we come in and have a little bit of time for questions, remember, send me an email so I can get you a free copy of the book, the poster, and of course the book references a lot of online resources, templates, open source build templates, things like that to help you get automated. But let's open it up for any questions that we have.
Thank you, Jeffrey. Yeah, guys, if you have any questions, just unmute yourselves and let's go one at a time. Or if you prefer, we can also use the chat doc. Yeah, do you have a question?
No.
Okay. I do have one, Jeffrey.
Yeah.
You mentioned that at deployment time, it's a little bit cumbersome at this time to use YAML or the pipeline as code implementation. In those kind of scenarios, I know that this presentation was focused on all the tool built from Azure DevOps, but would you recommend to pair up with other apps that you have found easier to manage these kind of situations?
From a tools perspective, or are you talking about legacy applications?
From tools perspective, right?
Yeah.
To this impact of
sure.
Not,
so the two different classes of tools that you need, you need a build server, and then you need a deployment server. Azure DevOps provides both with pipelines. It has the build capability and the release manager capability. It has deployment. GitHub Actions is rapidly being developed, and we see a lot of uptick. They started with the build and they're moving into deployment. Octopus Deploy, I think, continues to be the premier deployment server on the Microsoft platform. It was the first and it's the most comprehensive. It's very common to pair a build server with Octopus Deploy and have your suite that way. For SQL Server on the commercial side, Redgate SQL Change Automation is the most comprehensive commercial tool. If you don't need the integration, the tooling integration, you just want a simple command line tool, you have DBUp from Octopus Deploy, you have Roundhouse, and you have AliasQL. And those are free open source database migration tools that all pretty much work within the same architecture. And they are migration based. You don't want to be using a state-based or compare-based database deployment. The architecture is a little bit different. You don't want to have to look at deploy time. You don't want to have to look at a destination database and then decide what scripts to run, because that automatically prevents you from having any quality assurance process on what changes you're going to be making to the database, because you're letting the tool guess on what changes it's going to decide to make to your production database while it's deploying. And so you may trust the tool, but you have no way of knowing. You just kind of say, well, it's worked so far. But it only works in happy path scenarios. For example, if the change that you've made is to split a phone number column and get rid of the old column, there's no way that any kind of tool can guess how to make that translation. Or if you are deleting a column, or you need to move some data around, which is very common. So it's great for demos, but it breaks down in real life pretty quickly. But the database migration methods have proven to be rock solid. They provide a mathematical proof level assurance that what you decided to do from a database change perspective and what you tested, that is exactly what will happen in production.
Thank you, Jeffrey. And I just got, I didn't know about DBUp from Octopus, so thank you so much. I'm going to share it with my team.
Yeah, absolutely. All right. Well, thank you all. I think it's 1:01 p.m. Central Time. So I appreciate the attendance. And JJ, thank you so much for having me.
Thank you, Jeffrey. Just before we sign off for this, guys, if you can just text me on the chat group where you are joining us from, just to have a clear understanding of what parts we've gone through. One more time, thank you so much, Jeffrey. This presentation was way more than I expected, and I bet that it's not only my personal opinion. So thank you.
My pleasure.
And guys, if you want to see other kind of presentations like this, we're gonna come up the next month with the upcoming one is with the guys from Sonatype, the ones that have Nexus and other tools for artifact repos and DevSecOps. And specifically, this upcoming talk is going to be about DevSecOps. So please stay tuned, and we're going to send you the link for this presentation as well. Thank you so much, guys. See you next time.
Thank you. Have a great day.